This is Algebra 1, Term 5, Lesson 6, Rational Exponents. We'll begin by working an activity in Desmo's classroom, and then we'll go to our slides to do a little bit more inquiry and discovery before we tackle a graspable math activity. And then finally, we'll do a square of cards from Math Equals Love. So let's get started. So in Desmo's classroom, this should go quick. There's only 11 screens, so let's start. In the first screen, it's not really talking about rational exponents, but just exponents in general. So we want to kind of refresh kids' memory, and the way we'll do that is to have them do an open mental task. And if you've never seen one of these, they can grab these numbers and drag them into place. And it will tell them, it is self-checking when they get it correct. There is more than one correct answer to this problem. And then to make it a little more interesting, we're combining different properties. So we have the product and quotient rule in here. And so they're going to try to create an expression that is true. And then we're going to be exposed to the formal definition of rational exponents. Now you may have noticed there were some negative exponents on that previous screen. I'm not really expecting kids to use those, but they might. And if they do, they may discover something early, and that's fine. But in this lesson, we're going to learn what it means to have a rational exponent. Technically speaking, any rational number in an exponent would be a rational exponent, but for mathematics we tend to just stick with the fractions and the integers that are negative, maybe even zero, but if it's an integer exponent we don't really call them rational exponents. And here are some properties of exponents, and these properties apply equally to rational exponents. So these properties are being used in these answers, and 3 of them are correct and 3 are not, so they will find the 3 that work. Now in this one they're using a pattern to make a discovery, or at least I hope they make a discovery. Square root of 0 is 0, square root of 1 is 1, square root of 2 comes out to be 2, so what's going on here? Hopefully they notice when you square these numbers on the left you get the numbers on the right. Continue the pattern in the table. Alright, now they're going to continue the pattern in the table again, and they may notice these are exactly the same outputs even though the expressions on the left side of the table are different. And so the goal here is to continue that pattern by completing 2 more rows. They could do more than that if they want. And then using that pattern that they discovered, which expression would be the same as 5 to the 1/2 power? Choose an answer, click submit, and it will tell them if they got it correct. Alright, now using another pattern, let's complete this table. Notice the exponents are decreasing. We have 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and so forth. I'm kind of helping them out on that last one by showing them I do expect them to write a fraction and not a decimal. So if they're writing decimals here in these 2, because some of these kids are going to type these in a calculator, you might want to point out that that last row has a fraction, so maybe we should stick with fractions here. So let's encourage them to do that. And then on this one I did the same. I filled out a few on the left and a few on the right and left some gaps. Follow the same sort of pattern. Let's see if we can complete this table. And then once they've completed the table, they should be able to do this one. Use what you've discovered on screens 8 and 9 to find an equivalent expression for 5 to the negative 2 power. So which one makes sense? They also have the graphing calculator, so they can type in these expressions to compare them. And then finally, the last screen here is matching. So they will match up the expressions. I believe there's 4 different expressions written in different ways. So I think there's 4 stacks here. I did not put that in their instructions. As you see, it is self-checking. Let's go back to our slides. Now in the slides, the first thing they're going to do is graph. And they're going to compare the graphs for 2 different equations. They should notice they're coming out the same. That's kind of the point here. And using what they've observed, they're going to try to see if they can come up with another equation that would give them the exact same graph as this equation. So go back to this slide if they're not seeing it. Okay, what do you notice? Now, what can you do here? Try to make them the same. Then they're going to do the same again. They're going to do another observation with 2 different equations. and then they're going to try to create a second equation that would be equivalent to this one. On slide 6, they're going to graph 3 equations, and then on slide 7, they're going to create 2 more equations that are equivalent to this expression. For all of these screens, they will input graphs, and they will also include screenshots of the equations they've written. Our next activity is in graspable math. So graspable math has only goal state questions. They are a little bit tricky to do, so I'll just give you some pointers here. So in this first screen, students can basically change that to a 1 over 2 to the third. They may not know that right away, but hopefully they can see it from here. I'm kind of going a little deep in these, so this is not something they're necessarily going to master on day 1. This may come later, but we're just going to see what they're capable of. They notice here, hopefully in the goal, that the 3 is in the denominator, so try putting it there and see what happens. And look at that. It really is a one-step question. Same here. Just try dragging it into the space where it is and see what happens. And for this one, we can use properties of exponents. So when we want to put these together, we just put one on top of the other. And then here, this one is probably the toughest one because there is no fraction. So let me give you a suggestion. Get a fraction, however you need to get it. So I'm going to put this whole thing over 1. So we're going to divide by 1. So make that suggestion. I probably shouldn't have started with this expression. I probably should have put a 1, but this is the hardest one in the activity. Once they have a fraction in here, then it's a little bit easier to get the fraction in the goal. So to have them make a fraction by just putting the whole thing over 1 and then see what they can do with that. And then for this one, they can use the keypad to rewrite. Now that they know the 1/2 power is the same as a square root, they might be able to rewrite that using their keypad. That's true on all of these, and on some of these you could just type the answer, but hopefully they do more than just that. The goal of this activity is simply to play around with these rational exponents and make sense of them. So the last task we're going to do today is a card activity from Math Equals Love. So this rational exponents activity called Square Puzzle comes from Math Equals Love. And if you'll scroll down here, it shows you what it looks like. So you're going to have cards, and on all 4 sides of the cards will be expressions, and they're looking for an equivalent expression. Now that they know they can graph, that is one way they can make sense of this. She actually used this for a pre-calculus class, but technically speaking, these are Algebra 1 and Algebra 2 standards, so she was just doing some review with her calculus kids, so don't let that deter you. Once they've got these arranged in a square, then they're going to just take a picture of the square and put it on their slides. And that's all there is to it. She gives you some instructions for how she preps hers on certain types of paper, and she does a laminator and does all that. So if you're going to reuse this year after year, it might be worth the effort to go ahead and cut these out and do this yourself. But if you're doing it for individuals, you know, if each kid's going to do their own, then you would of course need their own. My suggestion is that you do these in teams. Okay, so in the activity, when you download it, it's going to look like this. She has different sizes, so if you have large groups, you could use the big ones. So if you have a team of 4 or more, maybe you do want the big ones. I would probably go with the medium-sized ones, just to save paper, and not like this size is probably good even for a team of 4. So they could cut these out and then start putting them together. And then there's the small ones. And that concludes our rational exponents lesson. Y'all have a great day.